You breathe it to live. I mean, every single second of your life, it is keeping you alive. But at the exact same time, it's this incredibly aggressive substance that is actively rusting your body from the inside out.
Right. It's actively accelerating your aging and damaging your DNA. It really is the ultimate biological paradox. We literally cannot survive without it, yet it's the very thing tearing us down on a microscopic cellular level.
Yeah, and today we are doing a deep dive into exactly how your body handles this paradox. We're pulling from Chapter 9, which is called The Fire Brigade, from Dr. Daniel Wallerstorfer's book, Unlock Your Genes for Precision Health.
Yes, and this is all part of the Nova Daily Genetics podcast series. The mission today is to unpack the exact genetic mechanisms that protect you from this internal rusting, what scientists call oxidative stress.
Exactly. And relying strictly on the science from this chapter, we're going to look at how understanding your specific genetics can completely change how you protect yourself. So let's just jump right in.
Yeah, to really grasp what is happening inside your cells right now, we need to look at how we handle massive natural disasters. Think about the 2019 California wildfire.
Oh, yeah. Those were devastating.
They were, in that year alone, there were exactly 8,194 recorded wildfires in California. It's just a staggering number.
Wow. Over 8,000 in 1 year.
Yeah, and when you break down the causes, 90% of those were human-caused. So we're talking unattended campfires, fallen power poles, glowing cigarette butts, and arson.
Right.
And the remaining 10% were just natural lightning strikes.
So you have a state that is, essentially a tinderbox. It's constantly under threat from human carelessness, but also just unavoidable natural sparks.
Exactly. And to fight those 8,194 fires, California have to rely on a massive, highly coordinated system. I mean, they need natural rain, sure, but they also have a highly equipped, relentless fire brigade.
Right. They've got the fire engines, the helicopters, water planes, just all engaged in this never-ending battle to neutralize those sparks before they consume the whole forest.
And that relentless, never-ending battle is the perfect mirror for the battle taking place inside you right now.
Because of the oxygen.
Exactly. The culprit sparking the fires in your body is oxygen. We think of oxygen as purely life-giving, but chemically, it is so aggressive it can make solid iron rust to dust.
Which is wild to think about happening inside of us.
It is. In your body, it attacks DNA, which can lead to cancer. It damages cell walls, proteins, and other crucial structures. And that accumulation of damage is literally what accelerates the aging process.
It's strange to think of breathing as a destructive act, but there is a specific detail about this destruction in the chapter that caught me completely off guard.
Oh, the alcohol connection.
Yes, because it's not just oxygen acting alone. The text specifically points out that when oxygen is combined with alcohol, it creates this highly specific targeted attack that kills brain cell connections.
Yeah, it's a very specific biological reality.
I mean, I always knew alcohol wasn't great for you, but the idea that it teams up with oxygen to actively sever connections in the brain is terrifying.
It really highlights just how volatile oxygen can be when introduced to certain elements.
Yeah.
But to understand how this baseline damage happens every day, even without alcohol, we have to look at the cellular machinery.
Okay, so what's happening at the baseline?
Well, about 5% of the oxygen that you breathe in doesn't just get used cleanly for energy. It actually gets converted into a toxic waste product inside your cells called superoxide.
Superoxide? I mean, that literally sounds like a supervillain molecule.
It kind of is. It's what we call a free radical. If we go back to our California analogy, a free radical like superoxide is a literal fire in a dry forest.
Because it spreads.
Exactly. It doesn't just sit there. It first damages its immediate surroundings, stealing electrons from whatever is nearby, and then it aggressively spreads in all directions. It causes this rapid chain reaction of cellular damage.
Okay, but if 5% of every breath we take turns into this aggressive, spreading biological fire, we should be internally combusting. Like, we must have our own internal fleet of fire engines and helicopters waiting for those sparks.
We absolutely do. Nature has equipped us with a highly specialized molecular fire brigade. And the very first protective shield, like the frontline responder, is the SOD2 gene.
SOD2. Okay, so let's think about where you'd station a fire engine. If superoxide is this dangerous, the body can't just let it float around waiting to be found, right?
Right.
So the SOD2 gene must be stationed exactly where the oxygen is being burned to create energy.
That is a perfect deduction, yeah. It operates directly inside the cell's own power plants, the mitochondria.
Oh, nice.
Because the mitochondria are the engines burning the fuel, they are exactly where the majority of these free radicals are produced. So SOD2 is stationed right at the source, waiting for a superoxide molecule to be generated.
So it just catches the spark immediately.
Exactly. When one appears, SOD2 neutralizes it before it can spread into a larger fire.
But the text mentions the neutralization process is pretty intense. The SOD2 gene doesn't just make it disappear, it converts the superoxide into hydrogen peroxide.
It does.
And I have to admit, that sounds like a terrible solution. I mean, hydrogen peroxide, isn't that the hard chemical people use to bleach their hair? Having that bubbling away inside our cellular power plants still sounds incredibly aggressive.
You're right. Hydrogen peroxide can indeed cause significant oxidative stress if left unchecked. It's highly aggressive. But this is the genius of biological systems.
It doesn't just leave it there.
No, the molecular fire brigade doesn't rely on just one unit to do everything. SOD2 is merely the first step in a relay race. It contains the immediate threat of superoxide, then it hands the problem off to a second responder.
Okay, so SOD2 downgrades the threat from a raging wildfire to, like, a localized chemical hazard. Who handles the cleanup?
Standing by is the GPX1 gene. This is the second unit of the fire brigade.
The GPX1.
Yes, the GPX1 gene is responsible for grabbing that highly aggressive hydrogen peroxide molecule and transforming it into entirely harmless water.
Oh, wow. That is incredibly elegant. So you go from the oxygen we breathe to the toxic byproduct superoxide. Then SOD2 steps in and turns that into hydrogen peroxide.
Right.
Then GPX1 steps in and turns that into water. Toxic waste literally becomes water. It's a perfect assembly line for neutralizing a threat.
It is a perfect assembly line, provided all the workers show up.
Right. Because here is where we have to look at the reality of human genetics. We've described this flawless relay race, but I'm guessing not everyone has a fully equipped molecular fire brigade.
Unfortunately, no.
Some of us probably have fire engines stuck in the garage or assembly lines missing crucial workers.
Yeah, the genetic reality is actually quite startling when you look at the population data. Genetic defects in these specific oxidative stress protection genes are extremely common.
So we aren't talking about rare anomalies here.
Not at all. Let's start with that first line of defense, the SOD2 gene. The chapter states that a good half of the population has a defect in one of their two SOD2 genes.
Wait, half the population is walking around with a compromised frontline defense.
Yes. And for that 50%, the superoxide is still detected and converted into hydrogen peroxide, but the whole process happens much more slowly than in people with two intact genes.
So the fire burns a little longer before the engine arrives.
Exactly.
Yeah.
But the statistics get more concerning. Into 27% of the population, both SOD2 genes are defective.
Wait, 27%. More than a quarter of the population has both frontline fire engines completely out of commission.
That's what the numbers say.
That means 27% of people are exposed to this harmful superoxide with severely limited immediate protection. The fire just gets to spread.
It does. And the situation isn't entirely foolproof for the second unit either, the GPX1 gene.
Okay, what are the numbers there?
Well, 67% of people have two functional GPX1 genes. They're fully equipped to turn hydrogen peroxide into water. But 26% of people have to make do with only one intact gene.
Okay.
And in 7% of all people, both GPX1 genes are defective.
Wow. So if you are in that 7%, even if your SOD2 gene works perfectly and creates hydrogen peroxide, your body has a severely weakened system for finishing the job and turning it into water.
Exactly.
You are just accumulating biological bleach in your cells.
Yeah, their entire molecular fire brigade is severely weakened. They are only partially capable of eliminating free radicals.
Yeah.
And that means the oxidative stress, the cellular rusting, the aging, the DNA damage accelerates.
Man, so if you are in that 27% with a defective SOD2, or that 7% with a defective GPX1, or God forbid, both your biological forest is going to burn.
It is.
The fire brigade is understaffed. That means we have to rely on the environment to help us out. We need natural rain to put out the fires.
Yes, the rain is our primary method for compensating for these genetic weaknesses. And in human biology, the rain comes in the form of certain vitamins and trace elements.
Which one specific?
Specifically, we are looking at vitamin C, vitamin E, selenium, and zinc.
Ah, the famous antioxidants.
Right. They are often nicknamed radical scavengers. When they are present in the body, they can step in and neutralize free radicals before they do damage. They basically act as a backup to your genetic fire brigade.
So if your genes aren't fit enough to protect you from oxidative stress on their own, you have to help them.
Exactly. By eating a diet rich in vegetables and fruit, or by taking appropriate supplements, you are literally bringing in the rain to compensate for your genetic gaps.
Okay, but if you are listening right now and thinking, great, I'll just go wander the supplement aisle and buy a massive bottle of vitamin C and vitamin E, we need to address the elephant in the room.
I think I know where you're going with this.
Yeah, there is a very common, very loud, skeptical argument out there that taking vitamin and mineral supplements just gives you incredibly expensive urine.
Right, the expensive urine myth.
The logic is that your body just flushes out whatever it doesn't immediately need, so you are just wasting your money. Is there any truth to that?
It's a fair question, and honestly, the skeptics are partly true. Most of the ingested vitamins do first travel through the body. They are filtered out by the kidneys, and they do, in fact, end up in your urine.
So it is a waste of money. We're just flushing it away.
Not at all. The fact that most of it ends up in your urine is completely by design.
How so?
Well, think back to the book's analogy of the burning forest in the rain. When a torrential downpour hits a wildfire, only a comparatively small number of raindrops actually hit the flames and extinguish the fire.
Sure.
The vast majority of the rainwater just seep into the surrounding soil, runs off into rivers, and seems wasted. But you absolutely need the massive downpour to ensure that those few critical drops hit the exact right spots.
Oh, I see. Or to look at a house fire, when the fire brigade shows up, they don't just carefully squirt a water gun at the visible flames.
Right, they bring out the massive hoses.
Yeah, they spray way more water than what actually hits the fire. They completely soak the entire house.
Exactly. And as any firefighter will tell you, soaking the house is not wasted water. Everything flammable in the vicinity needs to be drenched to get the fire under control and prevent it from jumping.
That makes total sense.
It is the exact same with antioxidants in your body. We need many, many more antioxidants floating around in our bloodstream than our bodies actually use in a given moment.
Because you don't know where the next spark is going to be. If superoxide is generated in a random cell in your liver, you need an antioxidant already there waiting.
Exactly.
You can't just send one drop of water and hope it finds the spark in time. You have to flood the entire system so the spark never has a chance to catch.
You are saturating the environment. The excess that gets filtered into your urine is simply proof that your system is fully saturated and prepared for any oxidative stress.
Wow. That changes the whole paradigm of how I view nutrition. But I want to zoom in on one specific drop of rain, one particular nutrient, because the text outlines a major difference between our two fire brigade genes.
Yes, there's the big distinction.
If your SOD2 gene is defective, it's just defective. But the GPX1 gene, the one that turns hydrogen peroxide into water, behaves a little differently, right? Its function revolves entirely around the trace element selenium.
Yeah, the relationship between the GPX1 gene and selenium is one of the most fascinating quirks in this entire system. We have to remember what a gene actually is.
Oh.
The GPX1 gene basically encodes a single instruction: detect specific free radicals and make them harmless. But a gene is just a blueprint on a piece of paper.
Right.
To actually carry out that instruction in the real world, the GPX1 gene contains the blueprint to build a small machine.
In biology, that machine is an enzyme.
Yes, an enzyme called glutathione peroxidase.
Okay, so the GPX1 gene is the blueprint, and it builds this enzyme machine to do the actual firefighting. But to build a machine, a factory needs raw materials. It needs parts.
Exactly. And to build this specific machine, the body absolutely requires the trace element selenium.
Oh, I see.
If the body doesn't have enough selenium available, it doesn't matter how perfect your GPX1 blueprint is. The gene cannot fight the aggressive free radicals because the production of the enzyme machine is physically limited by the lack of selenium supply.
So where do we get this crucial building block?
Selenium is naturally contained in certain plant foods. The best sources listed in the chapter are Brazil nuts, broccoli, mushrooms, and onions.
Okay.
And there's an interesting geographical note here. In the European Union, animal feed is often fortified with selenium, which means meat and eggs also serve as solid sources there.
Okay, so you eat some Brazil nuts, you get some selenium, your body uses it to build the enzyme machine. That makes perfect sense for a healthy person.
It does.
But what if your GPX1 gene itself is defective? If the blueprint is broken, how does throwing more parts at it help? Does eating broccoli actually fix a genetic defect?
This is where researchers made a remarkable discovery. If the GPX1 gene is defective, the enzyme machine it builds works less effectively. It's sluggish. It doesn't neutralize the hydrogen peroxide as fast as it should. And this happens even if you have totally normal, adequate amounts of selenium in your body. Your protection is reduced because the machine itself is flawed.
Right, a broken blueprint makes a slow machine, so how do we compensate for that?
Well, researchers observe that if the body is given more selenium-like higher amounts than what a normal person would need, the defective GPX1 gene automatically increases the overall production of the protective enzyme.
Wait, let me make sure I understand this. If the factory is producing slow, defective fire engines, giving the factory an overabundance of raw materials just forces it to build more of those slow fire engines.
That is a brilliant way to visualize it. The individual enzyme machines may still be less effective on their own, but by mass producing them through sheer volume of raw materials, the body can make up for their reduced individual function.
Wow.
A higher intake of selenium literally forces the weakened gene to boost its production numbers, which restores your overall protective function.
That is amazing. It's like the body knows the tools are blunt, so it just throws twice as many workers at the problem. And we have actual numbers on how many people need this, right?
We do. Based on the genetic data, there's a 38% likelihood that a person needs more selenium just to compensate for these GPX1 gene defects.
Let's sit with that for a second. 38%. Over a third of the people listening to this deep dive right now likely need a higher than normal intake of selenium just to force their defective GPX1 genes to produce enough defense against oxidative stress.
Yeah.
If they just follow standard dietary guidelines, they're basically walking around underprotected.
Exactly. It completely underscores how personalized biology really is. Some people need standard amounts of selenium to run their molecular fire brigade perfectly. Others need significantly more, and it is entirely dependent on the specific status of their GPX1 genes.
Okay, so we've established that we are highly dependent on our environment, on the rain, the food, the supplements to fix these genetic gaps. But I have to ask, does the body have any internal backup systems?
What do you mean?
Like, are we entirely reliant on chewing Brazil nuts and swallowing vitamin C to neutralize these fires, or do we have another trick up our sleeve?
Oh, we have a remarkably sophisticated internal backup. Food is not the only source of antioxidants. The human body actually has the ability to produce a highly powerful antioxidant entirely on its own, called glutathione.
Glutathione. So we manufacture our own rain.
We do. Once the body produces it, glutathione is distributed to the cells wherever free radicals appear. And it has one massive critical advantage over the antioxidants we get from food like vitamin C or E.
But yes.
Thanks to another specific gene in our DNA, glutathione is completely recyclable.
Recyclable? Wait, how does an antioxidant get recycled? Let's trace it. Say a glutathione molecule spots a free radical or dry forest fire. What happens?
It spots the attacker and immediately neutralizes it, preventing the damage. But in the process of neutralizing the free radical, the glutathione molecule itself becomes discharged. It loses its protective function.
So it's like a single-use battery. It gives up all its energy to put out the spark, and then it's just a dead battery floating around in the cell, completely useless.
Normally, yes, it would be useless. But this is where the GR gene steps in.
The GR gene?
Yes. The GR gene acts as a biological charging station. It recognizes this dead battery, the discharged glutathione, and it chemically charges it back into its original, highly protective form.
That's incredible. It recharges the battery so it can go put out another fire.
Over and over again.
I know.
Through the action of the GR gene, glutathione is constantly recharged so it can go right back out to the front lines and provide continuous protection as a free radical scavenger.
Wow.
It is the ultimate recycling system. It's designed to maintain our defenses against oxidative stress without constantly needing new external supplies.
It really is incredible how all these systems interlock. So let's bring this all together. We started by talking about oxygen as this ultimate paradox, the substance keeping us alive every second, but actively rusting our cellular structures, damaging our DNA, and accelerating our aging. We've seen that the body's solution is this incredibly complex, beautiful molecular fire brigade. But the core reality here is that genetic defects in this system are startlingly common.
Very common.
27% of people have both SOD2 frontline genes defective. 7% have both GPX1 genes defective.
But the most important takeaway from this chapter is that genetics is not destiny. If your first line of defense is disabled, or if your GPX1 blueprint is flawed, you are not helpless.
You can actively compensate.
Exactly. The right selection and dose of various nutrients bringing in the rain can completely offset those genetic defects and protect your body.
And that leads to a really empowering way to view your own health. I mean, having these specific genes analyzed isn't just about satisfying some biological curiosity. It can be a direct, actionable roadmap to slowing down your own aging process.
It really can.
Instead of standing in the supplement aisle guessing what you need, you could know exactly how many functional fire engines you have on duty. You could know if you are in that 38% of people who need extra selenium to force a defective gene to mass-produce slower machines.
Yes.
You could know exactly how much rain you need to bring in to protect your cellular forest from burning down.
It just shifts the entire paradigm of health from a generalized guess to a precise, customized strategy based on your own DNA.
I love that. The fires are going to spark. That is simply the reality of breathing.
Yeah.
But you get to decide how well equipped your fire brigade is. Keep questioning, keep exploring your own biology, and we will see you on the next Deep Dive.